Hello, welcome back. Today we're going to be doing another Boson NetSim lab. Today we're in the infrastructure section within Boson and we're going to be troubleshooting EtherChannel number 1. So our objective for this lab is to analyze, locate, and fix EtherChannel problems on your network, which can be caused by misconfiguration or incorrect design. So here is our topology for this lab. We have two PCs, one connected off of the access switch number 2, and one of them connected off of the access switch number 1. And then from there, we have redundant connections from the access to the distribution. And of course, you want to have redundant connections in case one of the links goes down. Then you have another link that goes to that same device. But spanning tree is going to block one of those connections at the layer 2 level to keep from having loops within our layer 2 network design. But you can configure EtherChannel, and that will make both of these links look to the other switch as one logical link. So, it'd be both of the switches that are connected via the redundant links. If you combine both of the links within one logical link, that would be an EtherChannel. And from the layer 2 perspective, it'll only see that one logical link, which would be the ether channel that's configured. And you can have more throughput with an ether channel because traffic is load balanced between the two links. So ether channel is always good to use if you can use it between two devices. So that's what we're going to be doing in this lab right here. And then we have, from our core switches, we have some connections out to our routers. And as we can see right here from this core switch, we can go to R1 or we can go to R2. So we have two connections out to these routers, which is good. So if one of them goes down, we could just use the other router. So it's some redundancy there as well. So we're going to keep our lab topology up here in the top left. We're going to do all of our instructions top right, and we're going to do our configurations down here at the bottom. So let's go ahead and get into our lab task. So it says complex network troubleshooting requires a structured approach. Network documentation that includes a thorough troubleshooting procedure can decrease the amount of time required to resolve network problems. Troubleshooting procedures should contain a process to diagnose problems and take the necessary steps to verify a proposed solution, resolve the problem. In this lab, this is referred to as a troubleshooting and verification plan. So, trouble ticket number 1, resolving bandwidth issues at the switch replacement. Due to a hardware failure, core switch 1 has been temporarily replaced with a non-Cisco switch until a satisfactory replacement can be delivered. Upon installation and configuration of the primary switch, upon installation and configuration of the temporary switch, there is a noticeable decrease of network bandwidth between the core and distribution layers. You are provided authorization to the access and distribution switches. You have been asked to determine and correct the problem. So, we have a problem, or we had a hardware problem with our core switch, but we're not able to access that one. So we're going to have to, it looks like our problem is between the distribution. So one of these, it'll probably be distribution switch number 1 and core switch number 1. So let's pull up our D switch right quick. Just go to D switch 1 and D switch 2 right here. Okay. And let's do an enable. And let's do a show ether channel summary just to see what we have, what we're working with. Okay, so it looks like we have a port channel number 1 with PAGP configured. We have port channel number 2 with PAGP configured. We have port channel 11 right here, which is configured with PAGP. So all of those are Cisco proprietary. But right here is we have okay, so I just noticed this. We have SD. So the capital D means that this port channel number 11 is in the down state. This ether channel right here is in the down state, and all of the rest of them have SU, and the U means in use, so that means that it's up and working. So we see that the fast Ethernet 09 and 010 or I, we have the I, which means they are standalone, so they're not being conducted right now as, you know, ether channel. They're not being combined into an ether channel. So let's do a show CDP neighbor, because I want to see what device is connected off of the, okay, so we can see right here that the fast Ethernet 09 and 010 are connected to core switch 1. And it said core switch 1 has been temporarily replaced with a non-Cisco switch. So since it's been replaced with a non-Cisco switch, we cannot use a proprietary protocol such as PAGP. Right here, it will work if it was a Cisco switch, but it's temporarily replaced with a non-Cisco switch. So we're going to need to change this port channel 11 to probably use a standards base like LACP for it to be able to work. So let's do a show run, because I want to see how this was configured from the start. So it looks like port channel number 11 right here, switch port trunk encapsulation.1Q, switch remote trunk, and we want to go to the fast Ethernet 0, which one was it, 08? We want 09 and 010. So let's go to 09 and 010, which is right here. And it was configured with auto mode. So we want to take that off. So let's go into configure terminal. Let's go into interface range, fast Ethernet 09 through 10. And we want to do a channel group. And that was channel group 11. Yes, channel group 11. So we want to do let me go back over some. We want to do a no channel group 11 mode auto to take that off. Good. Now we want to do a channel group 11 mode. And since it's we could do active or we can do on. I'm going to do active because it's a non-Cisco switch. So we want to do LACP. So we want to do active. All right. And okay, now look, we see that our line protocol for port channel number 11 is now switched to the up mode. So let's do a do show ether channel, if I can spell, ether channel summary. Well, I can just do port channel 11, can I? No, I can't do that. Let's do an ether channel summary. And we can see right here now that our port channel number 11 is SU, like all of the other ones, is using LACP because the core switch is a non-Cisco switch. And we can see now that our fast Ethernet 09 and 010 they have P's, which means they are bundled in the port channel and they are working within the port channel. So that is perfect. Let's go over to D switch 2 to make sure nothing needs to be configured over here. Let's do an enable. Let's do a show ether channel summary over here. And it's the same problem over here, it looks like. So the fast Ethernet 07 and 08 for port channel number 21 are using PAGP, and it has SD, which means it's in the down state. So let's do the same thing over here. Let's do a show CDP neighbor. Okay. And we can see that which interfaces were those. Those were the fast Ethernet 07 and 08. So that's right here, which with core switch 1 as well. So we need to do a configure terminal. Let's do an interface range of fast Ethernet 07 through 8. Okay. And let's do a no channel group 21 mode auto. Well, before I do that, let me do a running config to see how this was configured. So let's do a do show run. Let's go to the fast Ethernet 07 and 08. So we can see port channel 21 mode auto. Well, channel group 21 mode auto, I should say. So that's the way that was configured. So let's do a node channel group. We will write channel group 21 mode auto. Perfect. And let's do a channel group 21 mode. Let's do an active. Perfect. Let's see what happens. Perfect. It came to the upstate, which is what we want to see. So let's do a do show ether, if I can spell, EtherChannel summary. And we can see that our port channel number 21 now is running LACP, which is the standards base for EtherChannel, and not Cisco proprietary like PAGP. We have SU, which means it's up and in use, is for layer 2. And the fast Ethernet 07 and 08 ports are now bundled within the EtherChannel because we see the P's right here, which means bundled in the EtherChannel right there. So that is perfect. So that's what we want to see. So I believe that we're done with trouble ticket number 1, because it said it was between it says authorization. It says a network decrease between the core and distribution layers. So that was the reason why. So our core and distribution layers now should have the full network bandwidth that they're supposed to have. So trouble ticket number 2, optimizing network utilization. So it says system administrators have configured PC2 to operate as a file server handling requests from hosts that are connected to a switch 1. While executing load stress testing scenarios, it is discovered that the server is unable to deliver the expected bandwidth to the host. Other network traffic appears to not be affected. You have been tasked with finding the reason that the server is unable to utilize optimal network bandwidth and correcting the problem. Okay, so we have PC2 right here, and it says optimizing network utilization. So we have PC2 right here, which is connected to a switch 2. So if any traffic has to come from a switch 1, it says it's going to be handling traffic from a switch 1. So we're going to either be dealing with the A switch 1 to D switch 2, or D switch 1 and then down to A switch 2. So we know that we're going to be dealing with either the access or distribution layers right here. So let's go over to A switch 1 really quickly. Let's go over to A switch 1. Let's do an enable, and let's do a show. Let's do a show spanning tree, just to see how traffic would go. So we have let's look. This is the root bridge, okay? So let's go over to A switch 2, and let's do the same thing. Let's do an enable show spanning tree. Okay, so port channel number 2 is our root port right here. So let's do a show EtherChannel summary. So I want to see. Okay, so fast Ethernet 01 and 02. So let's do a show CDP neighbor. Okay, so that fast Ethernet, okay, so that connects to D switch 2. So we're going to go like, so the traffic should go from A switch 1 to D switch 2 to A switch 2 and then to PC2. Okay. Just wanted to be sure how that worked. Okay, so let's go back to A switch 1 now. And let's do a show EtherChannel. Okay, let's get some context sensitive. And we know that it's bundled within the port channel. So let's do you know, within the port channel, traffic is going to be load balanced between both of the interfaces. It's going to be seen as one logical interface, but both of the interfaces are going to be used because it's bundled within the ether channel. So you can load balance traffic between the ether channel. So let's between the two links. So let's do a show ether channel load balance to see how it's load balancing. So it looks like it's load balancing from the source MAC address. Okay. So over on this is on a switch 1, which is right here. So that means that each PC that generates traffic towards PC2 is going to use a different link. And the reason I say that is because each PC has a different MAC address. Now each of the following responses from PC2 is going to use, well, let's go over to A switch 2 now and see how it's load balancing. So let's do a show ether channel load balance here, load balance. So it's using source MAC address as well. So that may be the problem, because each request that it receives, the response from PC2 is going to use the same MAC address every single time. So it'll never load balance over the other link. It's going to use the same link every time. So we may need to change that to use a, let's see the options that we can do. So let's do configure terminal. And let's do a channel. I'm not sure how this configuration would work. So let me do an ether channel, maybe. No. Okay. So we're on port channel number 2. So I need to probably go into interface fast Ethernet 01 through 2. Okay, I didn't put interface range fast Ethernet 1 through 2. Okay. And if I do a channel group 1. Okay, so I can only do mode. Okay, so that's not correct. So, how do I change the load balancing method? That's what I'm trying to figure out here. So that's, okay, so let's do an interface port channel number 1 or number 2. Let's do number 2. And let's give some context sensitive. So you can't do that. Okay. I'm trying to figure out how you can configure the, let's get some context sensitive. I may need to, so what are we trying to do here? We're trying to change the load balancing method. So how do you change the load balancing method for a ether channel? That's what I'm trying to figure out. So let's do a channel protocol, maybe? I don't think that channel protocol can't be it. Okay, let's do a do show run. Just trying to think how I can change the load balancing method for that port channel. Let's do a port channel, and I may need to go ahead and just get some help from Boson. I hate doing that. But let's go in interface port channel 2. And let's do a spanning tree. No, that's not right. Okay, so I may need to go ahead and get some help for this right here, because I'm not sure how you can configure the cause let's do an exit right quick, and let's do a exit one more time, or maybe I can do a context sensitive help here. Okay, that's what we want. We want port channel. Let's do a port. That's what we want. A port channel. I think this is it. load balance. There we go. And we want to load balance it by, let's do instead of doing just the source MAC address, we can load balance it by, we can either do it by the destination MAC address, or would that be the same? No, it wouldn't, because different. You can either do the destination MAC address, or you can do the source destination IP address. So let's do, I'm going to go with the destination MAC address. No, I'm going to do the source and destination IP address. So source, destination, IP. Okay, let's try that out. Hopefully, I think now the responses from PC2 is going to load balance its responses based upon the source and destination IP addresses of, well, that'll be the source and destination. So yeah, I need to change this. I need to change it to the destination MAC. Let's do destination MAC. Let's try that. That makes a little bit more sense, because the destination MAC is going to depend upon, well, it would depend upon the PC that generated the traffic. So let's grade it. Hopefully we did everything correctly. I got a little bit confused on trouble ticket number 2, but hopefully we solved it correctly. Let's look now. Okay, so it looks like we did it wrong. Okay, so it wants us to load balance it based upon the source and destination MAC address. So it wants the combination of both. Okay, so port channel load balance on source and destination MAC. Now it should work. Okay, and let me think about that for a minute. Let me go back to my topology. Well, I can look right here. So if we load balance it based upon the source to destination, the source would always be the same. It's going to be PC2, but the destination would be different depending upon which PC over here generated the traffic. Because it didn't have to go back to that PC. It will be replying to that PC's request. So that makes sense, because the source will always be the same. So that's why right here it says that while doing the load stress testing scenarios, it was discovered that the server is unable to deliver the expected bandwidth to the host, because it's using the same link every time. But since we load balanced it over the source to destination, it'd be different upon the the way that the traffic is sent to the other PC will be based upon the source and destination MAC address, instead of just using the source, which will always be PC2. So that makes sense. I learned I learned a little bit in this lab. It was very helpful. Thank you guys for watching this one. I'll see you in the next one.